In this video lecture, I am going to discuss with you about the equation of continuity in fluid dynamics and the probability current density and its derivation with the help of the Schrödinger equation. And we'll also discuss in detail about the features of the current probability current density and its applications in different domains. Myself Virendra Kumar, professor and scientist, and you are watching Sai Academy channel. So friends, please stay tuned throughout all of the videos because this video is very important and it is going to be very interesting for you because these concepts are asked in many competitive examination and the academic courses also. So please don't skip and go through whole of the videos. So let's start. Friends, in quantum mechanics, the probability current density or probability flux is a mathematical quantity. It describes the flow of probability. If someone thinks probability as a heterogeneous fluid, then the probability current is the rate of flow of this fluid. It is a real vector quantity that changes with the space and time. Probability currents are analogous to mass currents in hydrodynamics and electric currents in electromagnetism. Friends, the probability current is related to the probability density function via a continuity equation which we will derive with help of the Schrödinger equation and the wave function. And for the wave function psi, the probability current is invariant under the gauge transformation. So we will also discuss about the probability density features and its limitations for the different domains. Let psi be the wave function of a of particles system of particle. Let m is the mass of particle which is confined because of potential v. Now let us write the Schrödinger equation for this system. So time-dependent Schrödinger equation IH cross del psi by del t is equal to minus h cross square by 2m del square psi plus b psi. Question number 1. Now let us write the complex conjugate for this equation minus I h cross del psi star by del t is equal to minus h cross square by 2m del square psi star plus v psi star. Equation number 2, where we have taken v, which is a function of position and time, as real. Now, to solve this for the continuity equation, multiply the equation number 1 with psi star and equation number 2 by psi and subtract from each other. So we'll get I h cross psi star del psi by del t is equal to minus h cross square by 2m psi star del square psi plus psi star v psi. So this is equation 1a, and minus is cross psi del psi star by del t is equal to minus h cross square by 2m psi del square psi star plus psi v psi star. So this is equation number 2a. Now subtracting these equations, you get I h cross psi star del psi by del t plus psi del psi star by del t is equal to minus h cross square by 2m psi star del square psi minus psi del square psi star. This will be cancelled out, which implies that I h cross del by del t of psi star is equal to minus h cross square by 2m psi star del square psi minus del square psi star into psi. So this is equation number 3. Now we will use a formula of the divergence of multiplication of the two function, that is, since divergence of any function fr into gradient of the function gr can be written as del f r in dot del gr plus fr del square gr. So we will use this relation to find the del of divergence of psi star del psi is equal to del psi star into del psi plus psi star del square psi, and this is equation number 4. Del of divergence of product of del psi star into psi is equal to del square psi star into psi plus del psi star into dot del psi. So we have two equations now, 4 and 5. Subtracting these two equations, subtracting these equations 4 and 5, we get del dot star del psi minus del dot del psi star into psi is equal to psi star del square psi minus del square psi star into psi. So we have del dot psi star del psi minus del psi star into psi is equal to psi star del square psi minus psi del square psi star. We will use this relation in equation number 3, that is I h cross del by del t psi star is equal to minus h cross square by 2m psi star del square psi minus del square psi star into psi. So we will substitute this value from this. So this will be equal to minus h cross square by 2m into del dot psi star del psi minus del dot del psi star into psi. After simplification, we have h cross square by 2m del dot psi star del psi minus del psi star psi. This quantity psi star is nothing but probability density. So we can write this as I h cross del p rt by del t. So now we have this equation. After simplifying this equation, we get del p by del t is equal to I h cross by 2m del dot psi star del psi minus psi del psi star. That can be written as minus h cross by 2 im del dot psi star del psi minus psi del psi star. That is equal to minus del dot h cross by 2 im psi star del psi minus psi del psi star, and this quantity is nothing but a current density or probability current, and that is denoted by J, that is minus del dot J, where J is equal to H cross by 2Im into psi star del psi minus psi del psi star. Therefore, this equation reduces to del P RT divided by del T plus del dot J is equal to 0. This is nothing but the equation of continuity in fluid dynamics. Further, we will discuss about the importance of this probability density, that is position probability density, and the divergence of this probability current. In this continuity equation, here the equality sign is 0. That means there is no net flow of mass. The total mass is conserved. If the quantity will be not conserved, then this value will be not 0, whether it will be greater than 0 or less than 0, depending on the net inward flow or the outward flow of the quantity. Now, since psi star psi is the position probability density and modulus of psi squared d tau represent the probability of finding the particle in the volume element d tau psi star psi or psi star. Probability density and modulus square psi d tau represents the probability of finding the particle in the volume element d tau, whereas the volume integral modulus psi square d tau is equal to 1 implies that the particle has to be found somewhere in the space, certainly. Now let us consider a probability for finite volume V enclosed by surface sigma. Then we can write volume integral psi square d q r is equal to volume integral probability density into dqr. Since here volume does not change with the time while probability density changes, so d by dt integral prt dqr over the volume V can be written as integral V del P by del T dqr, and that is equal to integral volume V minus del dot J dqr by using the continuity equation. So we have assumed that volume is invariable with the time while the probability density is changing. Then we are having this with the help of Gauss Divergence Theorem reduces to minus surface integral J dot n dA And this quantity d by dt integral v p r t dqr is known as the integral revolution of the continuity equation. Here, it is to be noted that if volume increases to infinity, surface enclosing the volume also goes to infinity. Now the probability of all physical quantity at infinity vanishes. Hence the probability current density at infinity goes to vanish also because wave functions at infinity vanishes. That means, sir, that means J dot dA tends to 0 as the volume and hence the surface goes to infinity. Also, we can interpret this equation d by dt integral volume integral p r t dqr plus surface integral j dot dA is equal to 0 as if psi is a wave function describing a single particle, the integral in this term is the probability of obtaining a value within V when the position of the particle is measured, and the second term will represent the rate at which the probability is flowing out of the volume V. Altogether, the equation states that the time derivative of the probability of the particle being measured in volume V is equal to the rate at which the probability flows into volume V. Now, I would like to discuss the probability current for the spin zero particle, and also I would like to mention that we are discussing the case in a non-relativistic quantum mechanics. Spin zero particle current density J is given by, as we derived the equation in a one dimension psi star del psi by del x minus psi del psi star by del x, and also we know that in 3D it's cast by 2 psi star del psi minus psi del psi star, which we also derive this. And if we substitute momentum operator P is equal to h cross by I into del, then this equation reduces to J is equal to 1 by 2m psi star momentum operator P into psi minus psi momentum operator P psi star. So this is current density in terms of the momentum operator. Now if we want to get the current density for a spin particle for spin zero particle in an electromagnetic field, then we will have to modify this term J is equal to 1 by 2 m psi star momentum operator psi minus psi momentum operator p psi star with additional term 2qa modulus of psi square. So just we added a extra term for the spin zero particle in external electromagnetic field, this term, where q is the charge on the particle and a is the magnetic potential vector. What if there is a spin s on the of the particle and it is in an electromagnetic field? Then in that case, that means spin s particle an electromagnetic field, then the current density will be given by J is equal to 1 by 2m psi star momentum operator psi minus psi momentum operator psi star minus 2qa modulus of psi square plus additional term mu s by s del cross psi star s psi, where s is the spin vector of the particle. With corresponding to the spin magnetic moment mu s and spin quantum number s. This is spin magnetic moment. So these are the current density formula for different system. Friends, I am going to discuss something important with you regarding the continuity equation. You can see this continuity equation. This is general with sink and source. Previous one, here there was zero, but I am assuming that there is a net sink or source. In the integral form of the continuity equation, here sigma is in any closed surface that fully encloses a volume V, like any of the surfaces like this. So closed surface should be like this. This can't be like this. It should not have any boundaries. The boundary should be closed. Like always the surface should be like this. Further, now here the quantity may be anything like charge, mass, energy, momentum, number of molecules. So here gamma is the net rate that quantity is being generated inside the volume V per unit time. When quantity is generated, it is called a source of Q. When quantity is generated, it is called a source of the quantity, and it makes gamma more positive. When quantity is destroyed, any quantity is destroyed, it is called a sink of the quantity, like sink of charge, sink of mass. And in that case, this gamma will be more negative. In a simple example, I would like to explain this meaning of physical significance of this continuity equation. Suppose this volume V is nothing but a building, and this quantity is a number of people in the building. The surface sigma consists of the walls, doors, roof, and foundation of the building. Then the continuity equation states that the number of people in the building increases when people entering the building, that is an inward flux through the surface, or decreases when the people exit the building, that will be an outward flux through the surface. And the next possibility is that the quantity increases when someone in the building gives birth. In that case, this gamma will be more than zero, and the quantity will decreases when someone in the building dies or sink, then this gamma will be less than zero. So this is the simple explanation of the continuity equation. So always this continuity equation is being followed in the nature, whether it is 0, less than 0, or greater than 0.